But the discriminant is just part of the quadratic formula, which you guys know pretty well. Now, we talked yesterday about how we can find the roots of a quadratic from factoring, from graphing, and from using your quadratic formula. Well, there's the feature of the quadratic formula that we're going to be looking at today is the part that is underneath the radical, that b squared minus 4ac. That part of the quadratic formula will tell you a lot of information about your quadratic and about the x-intercepts without actually having to do anything. Are you short, Zach? Okay, so the b squared minus 4ac is going to tell you a lot about the quadratic. So we're going to explore, there's 4 different cases that this discriminant, this set of numbers, is called the discriminant. So we're going to talk about what that tells us here. So case 1, suppose that the number under the radical, your b squared minus 4ac, is a perfect square. All right, so that's going to be case 1. So let's explore that here. Let's use that quadratic, x squared plus 3x minus 10. Okay, so we're going to calculate the discriminant. You don't have to do the whole quadratic formula here. We're just going to calculate this part. So what is the b in this quadratic? 3. So you'll take 3 squared minus 4 times what's a? 1 times c is negative 10. I want you to go ahead and grab your calculators and tell me what is the value of that discriminant. I'm going to put my calculator here for in a minute while you're doing that. So 3 squared minus 4 times 1 times negative 10. Nope, you should not get a negative here. You should get a perfect square. So that's the case we're looking at. We're looking at when the discriminant is a perfect square. What'd you get, Shane? 49. You should get 49 here. Did anyone not get 49? You didn't? Let me see your calculator. Oh, okay. All right, so would you agree 49 is a perfect square? Yes. Okay, so here's what we're going to do. Now, we are going to take that 49, and let's actually find the x-intercepts, bless you, of the calculator, or not of the quadratic, because once we know the x-intercepts of this quadratic, we can make a kind of general rule about what this discriminant tells us. So to find the roots, we are going to just use the quadratic formula. So let's just review a little bit yesterday. So of x squared, this will be a shortcut of quadratic. We take the opposite of b, so negative 3, plus or minus. Well, what did we already calculate was under the radical? 49. We already calculated that value. And it all goes over 2 times a. So this is a review of quadratic formula from yesterday as well. Well, what's the square root of 49? 7. Okay, so we get x equals negative 3 plus or minus 7 over 2. And we talked a little bit yesterday on your practice. We didn't do this in the notes yesterday. But we said when you get rid of a square root, and there's no I, so no square root, no I, you need to break this up for me into 2 roots. Okay, so I break it up, let's see, I'll do it this way. We need to do negative 3 plus 7 over 2, and negative 3 minus 7 over 2. Well, what's negative 3 plus 7? 4. 4 divided by 2 is 2, so that's one of the roots, one of the x-intercepts. And then I have negative 3 minus 7 is negative 10 over 2, which equals negative 5. So those are my 2 x-intercepts. Now, what the discriminant, the point of this is that this perfect square, the fact that my discriminant is a perfect square, without having to do the quadratic formula in the future, not right now, is going to tell me how many x-intercepts I'm going to have, so 1 or 2, and then the nature of them. What kind of x-intercepts are there? So we have 1, 2 x-intercepts. We're going to have 2 roots. And are they rational, irrational, or imaginary? Rational. So we have 2 rational roots. And when you have 2 rational roots, does that mean the quadratic is factorable? Yes. All right, so ultimately what we're going to be learning on this page is that case 1. If you calculate the discriminant and you get a perfect square, 4, 49, 36, 100, you're going to have two rational roots. Okay? That's what you need to know for your quiz tomorrow. All right, so if I look at the next one, let's talk about the next case. What if the number under the radical is positive but not a perfect square? Okay, so you get something like 41 or 22, 23 or 22. All right, so let's calculate the discriminant here. Start with b squared. So b here is negative 6. So negative 6 squared minus 4 times a is 1 and c is 7. So go ahead and calculate what is that discriminant. What's the value that would be under your radical here? 8, yeah. Now, 8, you would agree, is not a perfect square, correct? All right. So it's not a perfect square, so it fits the case that we're looking at. And we're going to find the roots so that I can figure out how many roots and what kind are they going to be. Bless you. So let's calculate. We have x equals, we're going to use our quadratic formula again. What's the opposite of b here? Positive 6 plus or minus the square root of 8. We already calculated that value. Over 2 times 1. So when I look at that, I have to think, can I simplify the square root of 8 at all? Yes, I can. Yeah, so square root of 8, you can do, if you need to, you can write it down off to the side. What perfect square does an 8? 4, so it's radical 4 times radical 2, which is simplified as 2 radical 2. If you can do that in your head, you don't have to write it down. So I'll have x equals 6 plus or minus 2 radical 2 all over 2. Now, does that simplify at all? Yeah. What goes into all those numbers? 2. So you should simplify that to be 6 divided by 2 is 3, plus or minus. It's the opposite of b. Your b is negative 6. All right, so then we'll have plus or minus 1 radical 2, but I don't have to write the 1. And then technically over 1, but do I have to write the over 1? No. So that's just 3 plus or minus radical 2. Are you okay with how we got there? Now, how many roots do we have technically? There's 2. 3 plus radical 2, and that's not a 2. 3 plus radical 2, and 3 minus radical 2. Right, there's 2 numbers there. So you have 2 roots. Are they rational, irrational, or imaginary? Irrational. So this time I have 2 irrational roots. So in the case where you get a discriminant, a number under the radical, that is not a perfect square, but it's a positive number, you're going to get 2 x-intercepts that are irrational. And can you factor that quadratic then? No. Good. Okay, good so far? 2 cases down, 2 to go. Let's see what the next one is. Case 3 where the discriminant is 0. So the number under the radical we should get is the value of 0. So let's start by calculating the discriminant. Make sure that we get 0 like we want. So we take b squared, so negative 10 squared, minus 4. A is 1, C is 25. That gives me 100 minus 100, which is 0. All right, well, that's a good thing. We wanted the discriminant to equal 0. So now let's figure out through this example how many and what kind of roots are we going to have. So we'll use the quadratic formula again. We have x equals. Now what's the opposite of b here? Ooh, 10, positive 10, plus or minus the square root of 0, all over 2 times 1. Well, what's the square root of 0? 0. So what you really have here is 10. Do I have to do plus or minus 0? No. So I have 10 over 2. And what's 10 over 2? 5. Well, how many answers do I get? I get 1. I get 1 root, and is it rational, irrational, or imaginary? Rational. So this time you're only going to have 1 rational x-intercept, or 1 rational root. So if your discriminant is 0, that thing under the radical, you have 1 x-intercept. Could you factor that quadratic then? Yes. Any rational root, you're able to factor. Okay. All right, we have one more case, and we're going to look at some pictures of these. Oh, pictures. I already drew the pictures for you. I was trying to be helpful on back there. All right, so the discriminant is less than 0. What's another way to say less than 0? Negative. Okay, so we want a negative discriminant here. So let's calculate and see what the discriminant is that we're getting. D equals the opposite of, or not, no, I was doing it wrong. Negative 8 squared. Sorry, I was jumping right to the quadratic formula. Minus 4 times A times 20. 64 minus 80. What does that give you, Shane? Negative 16. Okay, so that's good. We have a negative discriminant, negative 16. And let's find the roots one last time here. This will be your last time doing the quadratic formula with me today. So x equals, what's the opposite of b? 8. Plus or minus the square root of negative 16 all over 2 times 1. Well, what did we say the other day happens when you have a negative under a radical? You're going to have an I. It's an imaginary value. And what is going to be the square root of negative 16? 4i. So I have 8 plus or minus 4i over 2. And how does this quadratic simplify? Yeah, divide these both by 2. So 8 divided by 2 is 4 plus or minus 2i. Those are the roots. Now, how many roots are there? 2 of them. Right, there are 2 roots, 4 plus 2i and 4 minus 2i. And what kind of roots are there? Imaginary. So you have 2 imaginary roots. Okay? And can you factor a quadratic that has imaginary roots? No. Okay. So back from your paper, those rules, that's what you need to know for your quiz. Right? If you calculate a discriminant that's negative, you need to immediately be able to tell me, oh, that's going to have 2 imaginary roots. If you get a discriminant that is 64, which is a perfect square, it would have 2 rational roots. So all we're going to do on the back, we have a couple graphs to look at and a multiple choice. We're going to calculate the discriminant, and then we're going to decide what kind of roots they're going to have. I'm going to show you then the picture, and we'll make sure we know where the roots are. All right, but we'll make sure we can visually see what these are going to look like. All right, so let's write the very top here in case we need to. The discriminant that you're calculating is the b squared minus 4ac. That's on your quiz, right? So the quiz tomorrow will have the quadratic formula, and it will say d equals b squared minus 4ac. So let's calculate the discriminant in A. So b is 7, so you'll have 7 squared minus 4 times 2 times negative 4. And I want you to calculate for me what that discriminant is. What do you get as the discriminant? 81. Now, 81 is a perfect square. So without flipping over, see if you can remember. What kind of roots will this have? 2 rational. So you're going to have 2 rational roots here. Okay, so write that down. And then here's the picture for you. That's what your graph's going to look like. Okay, so if you want to sketch that on your paper, that's fine. That's the picture of your graph. Now you guys were pretty good at using your calculator the other day. Right? You guys did well on your quiz with graphing. So I'm going to save us a little time. I'm just going to tell you where the x-intercepts are. Okay, so these 2 rational roots happen to be at negative 4 and positive 1/2. Okay? Just trying to save us some time today. You can practice with your calculator on your own in a little bit. The rational roots cross through the x-axis at whole numbers or fractions. So now let's look at these. Let's calculate the discriminant there, see if we can remember. So I'll have D equals negative 8 squared minus 4 times 1 times 25. Figure out what the discriminant is here. What do you get? Negative 36. All right. What kind and how many roots are we going to have this time? 2 imaginary. Oh, yeah. So if you have I or a negative, so think about this. If you had negative 36 under a radical, when you simplified it, there would be an I. So there'll be imaginary roots. And here's the picture. This quadratic is kind of floating up in the first quadrant somewhere. Why are these roots imaginary? Why aren't they real? Yeah, because they're not actually on the x-axis, so there's no real roots, so there's nothing to label there for those. Okay. Let's try the next two. All right, let's calculate the discriminant. D equals, we take our B, 4 squared, minus 4 times 4 times 1. 0. Yeah, 16 minus 16 gives you 0. And if your discriminant is 0, how many, what kind of root are you going to have? Do you remember? One rational. One rational. Yeah. You'll get better the more you do this. I promise. So one rational root here. What that looks like is that your graph is going to come down. It's going to touch the x-axis and then bounce back off. And we'll talk more about why it's bouncing off the axis later on this school year. But for now, you can just label that x-intercept is at -1 for that graph. Okay? So it would come down and bounce off and pop back up. All right, last one here. Let's see, D equals, we start with -4 squared minus 4 times 4 times -7. Yeah, 128. Yeah, make sure you get 128 though. No? Try it again, because that's right. Okay. Should not get a negative. Make sure you put your -4 that you're squaring in parentheses. Now, if I have 128, is 128 a perfect square? No. So it's just a number, a positive number. How many roots and what kind are you going to have? 2 irrational. Right? And if you're having trouble thinking about it, remember 128 is the number that goes under the square root in the quadratic formula. So if you had radical 128, you'd have to simplify that radical, and it would still be an irrational number. The radical wouldn't go away. So here's your picture. It crosses twice. It looks very similar to the first graph in terms of it crosses the x-axis. Crosses twice. And I'm going to label here your roots. Your roots are -0.914. Right, so that's definitely not a nice number. And then 1.914. So those are irrational, but just so you can visually see, what does it look like to have 1 root, to have 2 roots, to have no roots? All right, good so far? We have one more. It's a multiple choice question. It's not too hard. This one's a pretty short, simple multiple choice question. And it says, which of the following discriminants belongs to a parabola that has 2 rational x-intercepts? Now, before you tell me, when I have 2 rational x-intercepts, what kind of discriminant am I going to be looking for? A perfect square. Which one of those is a perfect square? B. There you go. That's the answer. That's the whole thing. So you have plenty of time here today, almost 15 minutes to work on your discriminant practice. Now, we are having a quiz on this tomorrow. It's going to be a combined quadratic formula and discriminant. So I would go ahead and try some of that practice here. It'll help you. I have a little quadratic formula on there as well. And then when we start tomorrow, we'll have our quiz, and then we'll learn a new factor